Assalamu alaikum dear students. Now we are starting with the adsorption isotherm. Okay, so the amount of the gas absorbed on the surface of the adsorbent depend on pressure and temperature. In other words, the amount of the gas absorbed is a function of temperature and pressure only. Mathematically, it can be represented as X by M is equal to F into PT, where X is the amount of the gas absorbed on mass M of the adsorbent at pressure P and temperature T. If T is kept constant, the equation 5.2 becomes X by M is equal to Fp. Equation 5.3 gives the variation of X by M with pressure at constant temperature. Now dear student, when X by M is plotted against the pressure at the constant temperature, the curves will be obtained which are known as absorption isotherm. Iso means same and therm means temperature. So those are called absorption isotherm. Thus, an adsorption isotherm is a mathematical expression or a graphical curve which represents the variation of the adsorption with pressure at constant temperature. Okay, an increase of the pressure of a gas causes adsorption. The increase of the adsorption with the increased pressure is experimentally found to be proportional to the pressure but somewhat less. So, Freundlich put the adsorption proportional to the fractional power of the pressure. This is important. Okay, the resulting equation gives the relationship between the amount of the adsorbed and the pressure is known as Freundlich adsorption isotherm. So here your Freundlich has made a little change over here. X by M is equal to Kp raised to 1 by N, or else you can write X by M whole raised to the power N is equal to Kp, where X is the amount absorbed by M grams of the adsorbate at a pressure P, and K and N are the constant which depends on the nature of the adsorbent and the gas at the particular temperature. So herein you are able to see X by M versus pressure P. The graph is plotted at the different temperatures. So I hope it is clear. Next, when we talk about, see the graph is giving you about with the different temperatures, that is 195, 244 and 273 kelvins, and you are changing the pressure. So you are having the different curves over here. The relationship is generally represented in the form of a curve. The mass of the gas absorbed per gram of the adsorbate is plotted against the pressure. A study of the curve reveals that at a fixed pressure there is decrease in the physical adsorption with the increase in the temperature. This we have already seen, that if we are increasing the temperature, the physical adsorption goes on decreasing. Okay. This curve tends to approach a saturation or limiting value of the pressure. Dear student, this shows that Freundlich equation fails at the high pressure. It was not able to give you the proper prediction at the high pressure. On taking the logarithm on both the sides, we get x log x by m is equal to log kp raised to 1 by n. When we go for clearing it more, we go for getting log x by m is equal to log k plus 1 by n log p. This is the equation of the straight line. The validity of the Freundlich isotherm can be tested by plotting the graph, that is against your log x by m versus y coordination and log p on the x coordinations. Okay, if the plot is a straight line, the Freundlich adsorption isotherm is valid. This is how you can confirm it. Okay, the slope of the straight line, that is equal to tan theta is equal to a by b, that is equal to 1 by n. The intercept of the x gives you the value of log k. The Freundlich isotherm only gives an approximation about the behavior of the adsorption. Okay, the value of 1 by n lies between 0 and 1. So you can get this particular values over here. Equation 5.4 holds good over a limiting range of the pressure. That is giving you when 1 by n is equal to 0, you are getting x by m is equal to k, that is simply constant. Equation 5.6 shows the magnitude of the adsorption in the independent of the pressure when 1 by n is equal to 0 and when 1 by n is equal to 1. Here it is given that x by m is equal to kp, that is x by m is proportional to p, pressure. Equation 5.7 shows the magnitude of the adsorption is directly proportional to the pressure when 1 by n is equal to 1. Both equations are supported by the experimental result. I hope it is clear about your Freundlich adsorption isotherm, dear students. Now next we are going to talk about the adsorption from the solution phase. So let us see that solid surfaces can also absorb solute from the solution. For example, when an aqueous solution of acetic acid is agitated with the charcoal, a part of the acetic acid is absorbed on the charcoal, resulting in a decrease in the concentration of the acetic acid. This we have seen as one of the example. Also, when the litmus solution is shaken with the charcoal, it turns colorless because of its coloring matter is absorbed by the charcoal. To take another example, magnesium hydroxide becomes blue when it is precipitated in the presence of magnesium reagent, that is a blue dye. The color is obtained is due to the adsorption of a dye on the precipitates of the MgOH twice, that is magnesium hydroxide. So dear students, these are the examples which we are relating about that from the solution. Okay. However, adsorption from the solution is much less understood than that of the gases by the solid. Absorption of the solute has the following features. The magnitude of the absorption comes down with the increase in the temperature. Number 2, it rises with the increase in the surface area of the adsorbent. Number 3, the magnitude of the adsorption depends on the concentration of the solute. Number 4, it also depends on the nature of the adsorbate and the solute. Okay, Freundlich has made little change over here in the equation that he gave x by m is equal to Kc, where we were writing Kp, here it is Kc because we are talking about the concentration, not the pressure. So see the same raised to the power 1 by n. Taking the log again, the same we are getting log x by m is equal to log k plus 1 by n log c. It has been experimentally shown that plot of the log x by m against log c is a straight line which shows the validity of the Freundlich isotherm. So dear student, whenever you are getting the straight line equation over here, you can say that your that Freundlich adsorption isotherm is valid for that particular whatever the solution you can talk about. Okay, so after this we are going to do with the application of the adsorption in the next video.